At an altitude of 10,000 meters, an engine of a passenger aircraft suddenly exploded. The sparks lit up the cabin. What caused this accident? Could the pilots manage to land the plane safely? Let us look into the story of South African Airways Flight 103. On November 8, 2019, a British Aerospace 146 jet operated by a subsidiary of South African Airways was scheduled to perform a routine return passenger flight from Zimbabwe back to South Africa. The flight number was South African Airways 103. When the passengers and crew arrived at the terminal, they had no idea that this would be anything but an ordinary journey. On this flight, there were 4 crew members on board, 2 pilots and 2 cabin attendants, as well as 34 passengers. The aircraft, a British Aerospace 146 built in 1997, had undergone its last major maintenance on July 27, 2017. Before departure, the captain performed a walk-around inspection of the aircraft to make sure everything was in order. After confirming everything was in order, the captain entered the cockpit to join the first officer. Both pilots were South African nationals and held valid airline transport pilot licenses. The captain had a total of 8,895 flight hours, including 7,035 hours of experience on this aircraft type. The first officer had a total of 4,157 flight hours, but only 81 hours on this type. This was an evening flight, and all times mentioned in the report are in Coordinated Universal Time, UTC, which is 2 hours behind local time. At around 1600, passengers began boarding. Boarding was completed about 30 minutes later. The cabin crew started securing the cabin equipment, while the pilots obtained clearance for engine start and pushback. After engine startup was completed, the aircraft went through post-start checks and everything was operating normally. The plane then taxied to the holding point. The flying conditions that day were excellent. Wind direction 080 degrees, wind speed 12 knots, temperature 15 degrees Celsius, weather normal clouds and visibility. Flight 103 then reported to air traffic control that it was ready for departure and soon received takeoff clearance. The first officer aligned the aircraft with the runway centerline. After both pilots confirmed everything was correct, they pushed all 4 throttle levers forward. The engines advanced to takeoff thrust, and the 4 Honeywell RJ85 engines roared, driving the aircraft down the runway with accelerating force. At 16:45, Flight 103 lifted off smoothly, beginning its journey to Johannesburg, South Africa. The crew was then cleared to climb to a cruising altitude of 34,000 feet. All systems were functioning normally during the flight. At this point, passengers began to settle in, the seatbelt sign was switched off, and the aircraft soon entered its cruise phase. It was expected to remain at this altitude for the next 50 minutes. At 17:38, while cruising at 34,000 feet, the flight entered South African airspace. After the pilots established contact with the new air traffic control sector and completed the busy handover of flight information services, their workload eased. The pilots began to relax and discuss the upcoming approach and landing briefing. But when the aircraft was still 240 nautical miles from Johannesburg, approaching the top of descent, a sudden loud bang shook the entire aircraft. The plane immediately yawed to the left. When the aircraft was still 240 nautical miles from Johannesburg, approaching the top of descent, a sudden loud bang shook the entire airframe. The plane immediately yawed to the left. The pilots quickly took manual control, stabilizing the aircraft and beginning troubleshooting. Inside the cabin, passengers heard the loud explosion and felt the plane lurch violently to the left. Sparks outside the left-hand windows lit up the cabin, further intensifying the panic. In the cockpit, the crew carried out instrument cross-checks. Indications showed an engine failure. The advantage of the BAE 146 was that it had 4 engines, providing extra redundancy. But after inspecting the engine instruments, the crew was shocked to find that both engine number 1 and engine number 2 had suffered catastrophic failures. Engine number 1 showed no readings at all, while engine number 2 displayed persistent, severe vibrations accompanied by erratic fluctuations. Both of these engines were mounted on the left wing. From the cockpit window, the captain could see flames coming from the left engines. The crew decided to keep flying the aircraft under control without rushing into any decisions. At this point, a cabin crew member contacted the pilots. Some passengers reported seeing sparks coming from the left engines, and panic began spreading in the cabin. The pilots remained calm, asking the cabin crew to maintain order and assuring them that further instructions would follow. Because the engine failures had been so violent, a successful restart was almost impossible, and attempting it recklessly could cause even more serious problems. Following procedures, the pilots executed the in-flight engine failure emergency checklist, making sure to cut off the fuel supply to engines number 1 and number 2. The crew then discharged the fire extinguishers for engines number 1 and number 2 to put out any possible fire. Afterwards, they inspected the rest of the aircraft systems. With only 2 engines now providing thrust, the plane could no longer maintain its cruising altitude and began a controlled descent to an altitude sustainable with the remaining power. The crew could not determine the cause of the catastrophic dual-engine failure and feared that the 2 remaining engines might also be at risk. The captain immediately made a Mayday emergency call to air traffic control, reporting that they had lost 2 engines, were descending from 34,000 feet, and were evaluating diversion options. He added that a decision would be communicated shortly. ATC cleared the necessary airspace for Flight 103 to handle the emergency. Search and rescue units were put on standby, and dispatch teams were ready to act. ATC also contacted a nearby Air Force base, about 50 miles from the aircraft's current route, placing it on standby to receive a potential diversion. Meanwhile, the crew established contact with the airline's maintenance control center to report and discuss the situation. ATC informed Flight 103 that the military airbase was available at any time. After discussion, the crew decided to continue on to Johannesburg and attempt a landing at the destination airport. Although still 240 nautical miles away, they could perform a controlled descent to ease the load on the 2 remaining engines, gain enough time to brief the cabin crew and passengers, and repeatedly verify all emergency procedures. At this point, it was 17:57, 19 minutes since the initial explosion. By this time, the passengers had become quite uneasy. The pilots communicated with the cabin crew, explaining the plan. The flight attendants then briefed the passengers, informing them that the flight would continue to its intended destination. At 18:10, Flight 103 was instructed to switch to a dedicated radio frequency, 132.15. Shortly afterward, ATC informed them that runway 03 was in use. However, considering their approach heading, runway 21 was also available. The captain accepted runway 21 and checked the aircraft's performance to confirm whether it was sufficient for a safe landing on that runway. After completing the new approach and landing checklist, the crew began preparing for this unusual situation. Still, they were worried about the risk to the remaining 2 engines. The cause of the earlier failures was still unclear, and it was impossible to know whether the explosion had damaged the left wing. Although it looked intact from the outside, there was no way to be sure whether the internal structure or control systems had been compromised. The crew discussed lowering the landing gear early to test the aircraft's stability, but doing so would increase drag and put greater strain on the remaining 2 engines. Taking advantage of the extra speed from descent, the pilots first decided to test the flaps. The tension in the cockpit grew heavier. When the first officer placed his hand on the flap control lever, both men braced themselves, closely watching for any abnormal vibration or control issues. The first officer extended the flaps to the first setting. The captain and first officer listened intently and observed the movement. The captain then performed several slow turns to simulate approach maneuvers. The aircraft responded normally. They then decided to extend the flaps directly to the landing position. Following the same procedure, the first officer moved the lever carefully, watching and listening closely. The flaps deployed smoothly without problems. The captain again executed a few slow turns, and the aircraft continued to behave normally. Since the airplane was now configured for landing, to avoid the risk of retracting and redeploying them again, the crew chose to maintain this configuration for the remainder of the flight. With the current altitude, the aircraft could continue safely without putting additional strain on the remaining engines until landing was achieved.
At 1828, Flight 103 was handed over to approach control frequency 124.5. At this time, the aircraft was only 10 minutes from the runway. The cabin crew began briefing passengers on emergency landing procedures and preparing for impact. To ensure Flight 103's priority landing, all other aircraft approaching runway 03 were instructed to abort approach and enter holding patterns, so that Flight 103 could make a right turn toward runway 21. The pilots notified the cabin crew to be seated. The cabin instantly fell silent, leaving only the roar of the two remaining engines pushing the aircraft toward the runway. The crew completed the single-engine side landing checklist, fully focused on the task ahead. In the distance, they could already see emergency vehicles waiting. As the aircraft descended closer to the ground, the captain asked the first officer to disengage the auto brake so that he could feel the pedal pressure directly and control it as needed. Crossing the runway threshold, the captain made a slight right correction, aligning the nose with the runway centerline. At 1839, Flight 103 landed safely. The aircraft rolled out and vacated the runway, then carried out a rapid post-landing check. Escorted closely by emergency vehicles, it taxied back to the apron. After reaching the stand, the pilots shut down the two remaining engines and allowed all passengers to disembark. None of the passengers or crew members on board were injured. As passengers walked off the aircraft, it was clearly visible that both engines on the left side had sustained damage. When the crew inspected after disembarking, they discovered that engine number 2 had exploded. Fragments had been thrown into engine number 1, causing additional damage. This was later confirmed during the accident investigation. On the underside of engine number 2, the fourth stage turbine disc had torn apart. The fourth stage turbine rotor wheel was found lodged inside the exhaust casing, jammed between the turbine disc and the exhaust struts. A retaining nut was found stuck in place. All turbine blades from the disc had separated and been ejected, striking engine number 1. The reason the pilots first observed engine number 1 failing was because turbine blades from engine number 2 had hit its FADAC system, Full Authority Digital Engine Control, which provides digital control and engine status information. The blades also struck the fuel, oil, and pneumatic lines. Therefore, the failure of the fourth stage turbine disc in engine number 2 was the initiating event of the accident. Investigators reviewed the maintenance records and discovered that engine number 2 had been installed on June 2, 2013. Its fourth stage turbine rotor disc had already reached its service life limit a few months before this accident. On July 27, 2017, the fourth stage turbine disc was removed and replaced. However, during installation, the retaining nut used to secure the fourth stage turbine was reused. The investigation found that this retaining nut loosened during flight, causing the fourth stage turbine to detach. As for the reason for the loosening, the most likely cause was that the overspeed ring had been installed incorrectly. This was believed to be related to the lack of dimensional guidance for positioning the fourth stage turbine disc in the aircraft's maintenance manual. In addition, the maintenance at that time was carried out while the engine was still mounted on the wing. This created the possibility of slight misalignment during installation. Although the deviation was minimal, even a very small tolerance error could have significant effects. Maintenance engineers must maintain extremely tight tolerances. For example, the depth length of the fourth stage turbine rotor inside the engine must be within 0.13 millimeters. It was precisely for reasons like this that the overspeed ring may have been installed incorrectly, causing misalignment of the gear surfaces. This led to turbine overspeed, which in turn caused the retaining nut to loosen, the turbine to detach, and ultimately resulted in catastrophic failure. Since its installation, this retaining nut and the fourth stage turbine rotor disc had undergone about 320 flight hours and 248 cycles before loosening and separating from the low-pressure turbine shaft assembly. Here, many of the terms are highly technical and maintenance-related. To make it easier to understand, the core issue was that a retaining nut securing one of the fourth stage turbine rotors loosened. This allowed the turbine to shift and eventually break apart. The root cause was either the retaining nut's clamping torque being incorrect or the turbine's overspeed protection device, the overspeed ring, being installed improperly. Without proper protection, the turbine's rotational speed exceeded acceptable limits. The increased kinetic energy and vibration further accelerated the nut's loosening.
Because of this incident, the maintenance manual for the British Aerospace 146 series aircraft was revised. A new procedure was added for dimensional checks during installation of the fourth stage turbine rotor assembly. British Aerospace also issued a bulletin to all operators, including diagrams of the dimensional checks that would be incorporated into the updated manual. The outcome of this incident can be considered positive, since it could have escalated into a major disaster. Throughout the entire process, the crew demonstrated a very high level of professionalism, remaining calm, steadily controlling the aircraft, and successfully completing the approach and landing.